So again, for this one, it wants us to use the two functions, the graph here and the function here, and determine which one has a higher maximum value, not a minimum, but a maximum. So again, we're going to look at the graph. The graph is generally the easiest one to identify the maximum. So we're going to look. Here's our vertex, and that is at -3 and 3, which means our maximum here for the graph is 3. So now let's do some math here. Let's figure out what our maximum is. So to do that, we need to find out our x axis of symmetry using -b over 2a. All right, so in this case, we know that a is going to be -1, b is going to be -4, and c will be -3. Plugging in, we get a -4 over 2 times, and a happens to be -1. So -4 is 4. 2 times -1 is -2. Simplifying that, so we get our axis of symmetry to be -2. Now let's plug that in. We're going to have negative, and we're going to square it, and then squared. So then we have -4 times -2 minus 3. So let's simplify. -2 squared is 4. Don't forget about the negative though. -4 times -2 is +8 minus 3. All right, so we have -4 minus 3 is -7. So we have 8 minus 7, which is 1. So the max here is 1. Okay, so let's compare. So the max is 1 here, and the max is 3 here. So clearly the graph has a higher function. So let's take a look at how we put that in a sentence. Okay, so we will say, so the max of 3, we're going to call this function f of x. So this is g of x, so f of x has the higher maximum value. So we'll say the function f of x's max of 3 is higher, or we could say greater than, the function g of x's max of 1. So there's our complete sentence.